Dear third-year students, this is our 8th lecture of forecasting. We will start at the centered moving average. Centered moving average, as we explained in the simple moving average, we require an odd number. There is the 3-order simple moving average, 5-order, and 7th order, and so on. Okay, so we need an odd number of observation to be included in each average. But in many observations or in many data sets, there is even number of the observations. This was to ensure that the average was centered as the middle of the data values being average. But when we suppose that we wish to calculate a moving average with an even number of observation, for example, if we want to calculate a 4-term moving average or 4MA for the example that we explained, the trend cycle at time 3 could be calculated as: we will add the first 4 observations and divide them over 4, so the result will be 178.6. and we want to make another centered moving average. We will add the second observation, the third observation, the first observation, and finally we will add the 5th observation, and we will divide it or divide them over 4. So we should to know that it should include 2 terms on the left and 1 on the right of observation. Okay, or 1 term on the left and 2 terms on the right. The center of the first moving average is at 2.5, which is the half a period early, while the center of the second moving average is at 3.5, which is half of a period late. Okay. The average of the 2 moving average is centered at 3, just where it should be. Therefore, this problem can be overcome by taking an additional 2-period moving average of the 4-period moving average. This centered moving average is denoted by 2 times 4MA. The results of the following centering procedure are shown in the following table. This is our example. The first column is given, the second is given, and the third is given. Finally, we can make the 4 moving average and put the result here in this table. And we will make 2 times 4 moving average. The following notation is useful in discussing weighted and centered moving average. For example, T 2.5 equal to y1 plus y2 plus y3 plus y4. This is all of these over 4. And the second moving 4 moving average is y2 plus y3 plus y4 plus y5 over 4. When we make averaging of these two for moving average, we will add this t of 2.5 plus t of 3.5 over 2. So finally we can summarize what I said. The simple moving average required an odd, but in some cases there is even number of observation. So the center of the first moving average will be 2.5, while the center of the second moving average will be at 3.5. This problem can be overcome by taking additional 2 period moving average of the 4 period moving average. So the centered or binary moving average is the simple moving average of length 2 of a simple moving average of length k. The simple moving average required an odd number of observations to be included in each average. This was to ensure that the average was centered at will be centered at the middle of the data values, which is being averaged. But suppose we wish to calculate a moving average with an even number of observations, for example, these two moving averages. This is the first moving average of the first 4 observations, and this is the second moving average of the latest 4 observations. So we will take the first 4 observation and taking average of them and put it on this column, which is the column 4, and so on. We will take the second, which is February data, March data, April data, and May data, and make the average of them and put it here, and so on to reach to the final one of the data. So we will take 2 by 4 moving average by summing the first and the second 4 moving average and dividing them over 2, or taking the 2 moving average of the 4 moving average. You will take the first 2 moving average, which is 178.6 plus 157.2 over 2. This is the first 2 moving average of the 4 moving average of the data. And this table will be is the centered moving average, which is the 2 by 4 moving average is obtained by averaging 2 successive values, 2 successive values of the 4 moving average of column 3. Okay, the 67.9 in the 5th column can be obtained by adding 178.6 plus 157.2 over 2 and 160, which is the second value of the fifth column, can be obtained by adding these two values, which is 157.2 over plus 162.8 over 2, and so on, to reach to the final of the table. In general, the moving average 2 times k, or 2 by k, is equivalent to simple moving average of the length k plus 1, where the observations are weighted by 1 over k, except the first and the last observations, which are weighted with half k. And let's make or take a note that moving average 2 by 4 used with quarterly data, and MA 2 by 12 used with monthly data to remove the seasonal variation effect. Let's turn to the double moving averages. The double moving average is the centered moving averages are an example of how a moving average can itself be smoothed by another moving average. Together, the smoother is known as a double moving average. In fact, any combination of moving averages can be used together to form a double moving average. Centered moving average is a generalization of the binary moving average. For example, moving average, which is the 3 by 3, is a double moving average of the simple moving average MA3. We can take it through. This is a year, and the second column is a number of students. The third column is MA3, or in order 3, and we can make let's take 1 minute, please. So we can write here that we can make a column here of the double moving average, which is MA3 by 3. Okay, it will be the average of the first moving average of order 3, the second and the third. All these values will be divided over 3, and we will put it here, and it is the moving average 3 by 3, and so on, to reach to the final of the table. This is another example of the double moving average. We take the weighted moving average, which is the summation of the weights multiplied by x or y. This is another example here, and please write those examples. This is the first example. This is a second one. And this is the third one. This is the fourth one. Let's turn to the decomposition of the time series. In a additive model, each component is represented as numbers, not percentage. But in the multiplicative model, it is preferable. In time series analysis, we assume that the series components are independent. To compose the series and estimate each component, we should follow the following steps. Firstly, we sketch the series. Secondly, we determine the trend. Number 3, we will determine the cyclical variation. We will determine the seasonal and irregular variation. We calculate the seasonal index. Number 6, we determine the irregular variations. Finally, we will predict the determination of trend. Trend, as we know, is the most used component in prediction. The main idea behind the trend analysis is to obtain a straight line or curve that describes the series in a long time period. There are different methods to determine trend component. Method number 1. By hand, draw a straight line passing through close to most of the scattered points. This method is very simple and easy method, but it's not reliable and not accurate and can't be used in general. If we need accurate results, in this case we can use other methods. The method number 2 is the moving average. The moving average eliminates the seasonal and irregular variation, hence the moving average keep the trend and cyclical variation. The moving average series is less fluctuated than the original series. Method number 3 is half split averages. The series is divided to 2 equal parts. Calculate the average of each half and connect the 2 averages to obtain the line. Number 4 is the mathematical method. We will use the regression method. A time point is chosen as a base year. At the start or at any point of the series t equals 0. We assume that the relationship between t and y is linear. We obtain the regression line of y on t. The equation is, as we take in the regression, y hat equal b naught plus p1 t. The parameters can be estimated as p1, which is the slope, equal to the summation of y minus y bar times t minus t bar over the summation of the squared deviation between t and t bar. and the intercept will be equal to y bar minus b1 t bar. Let's take this example and terminate on it, and I'll explain this example in the second lecture. We want to find 6 requirements. The number 1, we should plot the time series. Number 2, obtain moving average in order 3 and in order 5 and plot them on the original series. Number 3, we will use the half split averages to determine the trend. Number 4, obtain the trend or regression equation using 1994 as a base year and obtain the forecasted value of sales in 2004. Number 5, we will eliminate the trend component from the data. Number 6, we will obtain the trend equation using mid of 1998 as a base year and obtain the forecasted value of sales in 2004. Please solve it and try to solve it necessary. Thank you for listening.